All right, man. So we're back, Build 2013, day 3 of Channel 9 Live. Really excited to have Douglas Crockford and Steve Lucco with us. Thanks for joining us, guys.
Thank you.
Right on. So we're going to talk about JavaScript today. So you're watching this underneath the player, you know the drill. Type in a question about JavaScript. Certainly, these esteemed gentlemen can answer pretty much anything you could ask in that domain. But right off the bat, Douglas, what have you been up to?
I'm working at PayPal now.
Oh, okay.
And I have a secret project which is intended to save the world.
Okay.
Nothing to report yet. It's still a little preliminary, but early indications are good.
Awesome. And Steve, you've been doing a lot of work in the TypeScript and the JavaScript engine, of course, but what's going on?
Well, so we're getting ready to ship our Internet Explorer 11 with the new JavaScript engine. And it's been improved quite a bit from IE10.
Wow.
In fact, you'll see. Can't reveal anything too much, but there's going to be some benchmarks that just pop, that just jump way out there, and we've improved big app performance by a great amount, and we're really excited about that that Chakra release.
Excellent.
And TypeScript, of course, is chugging toward its 1.0 release. We just released the 0.9, which has the generic support.
Yep.
And also support for scalable language services. So even if you have a huge project, hundreds of thousands of lines, the response time of the language service stays immediate. So you get your member completions and your go-to definition right away.
Awesome. Which is the benefit of using that, because you get the design time experience.
That's right. With TypeScript, all the type system melts away at runtime. No runtime impact, and it's just for tooling. Just to help teams express interfaces and code guidelines and then enforce them at design time so that they can have more assurance that they are all agreeing on what they're doing.
Excellent. And of course, underlying it all is JavaScript, right? It's all about JavaScript. So let's talk briefly. I mean, what's your impression of where we are today with how people are using JavaScript? Does it blow you away? Does it freak you out? What's going on?
Oh, we're all over the map. There are people now writing absolutely brilliant JavaScript, and we've always had people writing absolutely terrible JavaScript, and everything in between. So it's good in that we see the number of people who are doing the good stuff increasing, but I think the number of people doing the bad stuff is increasing faster.
Really?
Yeah. Well, they misspelled my name there.
Not quite the way you spell the gentleman's name, but it's Crockford, C-R-O-C-K. But you know who he is. Right.
Yeah. So part of the difficulty is that JavaScript is such an unconventional language, but it looks exactly like a conventional language. And that's a big source of confusion, and so a lot of people have trouble understanding what they're supposed to do and no way of knowing if they're doing it well or not.
Interesting. What do you make of that, Steve?
Well, I'd actually like to ask Douglas about that. I know in your book, Good Parts, you advocate using closures, maybe even over like the prototype inheritance pattern. But one thing we found in building a script engine is that the prototype pattern has some better memory characteristics, because when you build the closures, each function member, for example, allocates a new object. So when you instantiate one object, you may get many other objects instantiated. So how do you reconcile? I completely agree with you. The elegance of the module pattern, or using closures, is great. But how do you give advice to people about when they should use those and when, for performance reasons, they would need to go with prototypes?
Right. So it depends on how many instances you're going to generate. If you're generating fewer than 100, it's in the noise, right? Those objects just don't add up to much. If you're doing thousands or more, then it might matter. Although in most web applications, you don't see thousands of instances. But if you do, prototypes are an appropriate thing there. So I think the concern about memory, which is real if you're in the big numbers, is just a distraction in the small numbers. And since that's where we tend to spend most of our time, that's where we write most of our code, is in the small numbers of instances, I think you're better off with the module patterns there.
That makes sense to me, and I think if I were to write a couple thousand lines of JavaScript, I would probably tend to use the module pattern. In fact, we have people using TypeScript who use TypeScript with basically modules and interfaces, and they express the module pattern quite elegantly that way. But a lot of our customers, at least the TypeScript ones, they have hundreds of thousands of lines of code. So like Xbox Music is over 500,000 lines of JavaScript, and they're instantiating sort of tens of millions of instances. And there we've had to work with them, and they naturally are using the prototype pattern.
Mm-hmm. Cool. So we have some questions coming in. Thomas, we can't really talk about the future. Let's keep it technical. I know we talked about ASM.js in our interview we did, Steve, but that's not really a technical question. Zippy wants to know, what's the difference between compiling JS to machine code and IL to machine code? Because at the end of the day, you get the same, you would think, on the other side, right?
Well, that's an awesome question.
Zippy V.
Well, so Zippy V, the thing is, it's a lot more fun to build a JavaScript virtual machine than to build a virtual machine for a nice, easily typed static object-oriented language, because you have a lot more creativity you have to bring to bear in order to get performance. So one of the things is that I can call a function, and that function can change all of the types of all of the properties of my object, and then I thought that a particular property of my object had an X property or a Y property, but it doesn't anymore. So it's then a more interesting challenge to write straight line code that goes and picks out that X property that might not be there. And so what you need to do is, well, first of all, you need to write code that adapts to all these possible changes in what the object shape is. And that code runs pretty fast, and that's kind of where you start. But then as you learn more about what people actually do with JavaScript, you need to start doing this thing that we've done a lot more of in IE11, which is taking bets. And so that's where you observe the code in the wild for a while, and you run it using polymorphic, which means code that can handle just about any type that the object has. Okay. And then you find out what it really does. And then once you know what it really does, then you generate code for that, but with a check, a bailout check. So if something goes wrong and someone deleted a property or something like that, an unusual thing, then you still execute the semantics correctly, but most of the time you have very specialized code. So none of that you have to do when you generate IL, for example, say from C#. Actually, I've written a C# compile that generated IL, and it wasn't easy either. But a lot of the trickiness had to do with features like iterators that make you make state machines and that sort of things, or features like async are quite challenging because the code that appears is nothing like the code you have to generate. So there's some higher level things with compiling C#, but actually generating the virtual machine code, much harder with JavaScript and more rewarding in the end.
Interesting, very interesting. So what's new for ECMAScript 6, Andre wants to know?
A whole lot of stuff.
Okay.
Some of it is great stuff, some of it is, I think, unnecessary stuff. I'm hoping there's not going to be any bad stuff, but we won't know for a few years yet. My favorite new feature in ECMAScript 6 will be proper tail calls. So if the last thing a function does is return the result of calling another function, the virtual machine or the compiler is allowed to generate a jump instead of a subroutine call return sequence, which optimizes things and lets things go faster. It allows it to manage memory more cleverly. It allows for continuation passing style programming, which is an amazing advance. So at that point, JavaScript becomes a real functional programming language.
Interesting.
It'll be good news for people who are trying to write other languages that compile into JavaScript as well, because they would like to have a low-level go-to statement to do control flow management, and this gives it to them without the danger that comes with go-to syntax. So that's going to be great. My second favorite feature is the ... operator, which we can use in parameter lists and in function invocations. It replaces the horrible arguments array and allows us to take all the extra stuff and put it in one array, which comes back as a real array that's clean, or to take an array and spread it out so we don't need to use the apply method anymore.
Okay.
Brilliant stuff. And a lot more. I don't know how much time you want to spend on this.
Yeah, I mean, we can't enumerate through them all, but what about you? What are you looking forward to, Steve? I mean, you're going to be implementing this.
Actually, I love ... Looking forward to implementing the tail calls in the Chakra engine. ECMAScript 6 is also doing classes, and those are aligned with the TypeScript classes. Actually, it's the other way around. TypeScript classes are aligned with the ECMAScript 6 classes. So I think that's going to be a useful feature for people, easier to type than .prototype.x equals kind of thing, a little easier to read.
Cool.
A feature I'm excited about in ES6 is generators. And one of the things I'm excited about generators is that once you have generators, which is kind of one of these things, not unlike C# iterators, where you have sort of a yield type statement, and then behind the scenes that's programmed so that you can enter a function, yield something, re-enter.
Okay.
That pattern enables you to implement things like async on top fairly easily with not too crazy a transformation. So that'll allow us to do things in future versions of things like TypeScript to do async, emit generators, and people will still recognize their code.
Nice.
It'll be a clean transformation, which is when one of the key goals of TypeScript has been to you see what you wrote. It's a nice, straightforward, linear transformation. So we want to preserve that. So we've left async for future versions of TypeScript, but generators will enable that. So that's a great feature. Another great feature, private names.
Private names.
Which is where you can get actually true privacy using the prototype pattern.
Okay.
Whereas only before, the module pattern was the only way to get actual runtime enforced privacy of a member of something. So that's a great feature too.
That's awesome. Seems like it's really cleaning up, really maturing.
We're hoping so. The biggest problem is that it's late.
Yes.
It should have published last year. Then we hoped it would publish this year, and it's not. We're now hoping it publishes next year, and it's not certain. So it is a very complex language, and it is taking much longer than expected to specify. So there are features of the language which are so important and which we should get out immediately, but they're being held up now for all the rest of it.
It seems like you guys have C++ envy, right? It took them 10 years to get to the latest version. All right, but you know what? Their next one's coming out in 3 years, so now you can play that game.
Well, we were hoping to. So the previous edition, the 5th edition, it took 5 years.
Sure.
And we were saying we're not going to make that mistake again with the 6th edition.
Right on.
We're now slipping a year per year, so it's not clear.
So Stan would like to know your take on adding cryptography APIs to JS. Some security experts believe that it's a flawed concept outright due to the malleability of the JS runtime. Your takes?
Well, it depends on what you're going to do with it. So having them built into the system is certainly better than you trying to write your own crypto, which is always a really bad idea. But because the JavaScript environment, at least as practiced in the browsers, is not a safe environment, it depends on what you're going to use it for. Because whatever information you're planning to encrypt, the attacker probably also has access to the same information and to the same algorithms. So if what you're trying to do is protect stuff that you're going to give to another system or crossing some trust boundary, then it might make sense. But it would be even better if you were using SSL or something that's going to wrap that for you automatically.
Interesting. So Steve, one thing I would ask there is, with cryptography APIs, a lot of people are using ones that have been written in C. And they do that because of performance. You want to be super fast to decrypt and encrypt something, yes? So
Yes,
would it be a difficult thing to actually do in your world to implement an efficient cryptographic implementation?
Well, we had some experience. There's some crypto benchmarks. For example, in SunSpider, there's a crypto piece and so on. And, these days, we are getting pretty good at numerics.
Okay.
And some numerics are running very close to native speed now, depending on you know, if you do a lot of object accesses in the inner loops, it's going to be not nearly as good as native. But if the inner loops are predominantly numerical, especially if you use typed arrays, there's a lot that can be done.
Awesome. And that goes back to like ASM.js, which leverages typed arrays.
Yeah, that's right. I mean, that's a really interesting future direction that I think we're all looking at.
Right on, man.
It's a good technology.
It's amazing to me that every day, like every week, I read something like, "Hey, we just implemented Linux," and that's kind of dramatic, but I mean, what can't you do in J? It blows my mind the things that. And why do you think that's the case? Do you think that's the case because JavaScript is such? It kind of leads into this question a little bit in terms of the dynamic nature, the sort of very flexible nature of the language itself.
Two things happened. One is Moore's law has been running unabated for a long time, and so the CPUs have just gotten so fast and the memories have gotten so big that most of the things that prevent JavaScript from working have been solved in hardware. But then we've got these brilliant JavaScript engines which are now starting to approach the speed of the compiled languages. And so, yeah, there doesn't seem to be anything that you can't do anymore.
Well, Charles, you know, I'd put my faith in the community rather than like the structure of a particular technology. I mean, I think what happens is enough energy goes in, enough group of people get together, and we find ways. So, like, I would, when we work on the engine and we plan for the next release, we say, okay, well, what scenarios are we going to enable in this release? And each time we try to broaden what you can do with JavaScript. You know, so HTML5 games, we've got it to the point where they're running really well. Things like ASM.js, as they come online, they'll help you replace the kernels of those games with things like, say, a physics engine. Maybe you write it with ASM.js, you get near native performance, your frame rate goes up. So I think it's a lot like, you know, the x86. Like, I remember being at Berkeley, which is a great one of the places where RISC came out, and we were all like, well, when is x86 gonna die? You know, RISC is such a more elegant architecture. You know, and that was a while ago that I was at Berkeley. So, and still x86 is chugging along. I mean, I think a thing that the community agrees to work together with, we find ways. Another example is, sure, maybe C++ is going to run faster on the CPU. But for example, suppose we were to create standards by which you could use the GPU with JavaScript and you know, write a little shader code that does your physics engine or your image transformation or something. There's always ways. And I think it's more important to really join the community and work with them.
Absolutely. To
try to make the class of applications broad.
Awesome.
That's the path we're on.
Excellent. So speaking of community, Lauren wants to know which feature that isn't in ECMAScript 6 do each of you wish JavaScript had?
Decimal arithmetic. The most reported bug still in JavaScript is that 0.1 plus 0.2 is not equal to 0.3. And when you're adding up people's money, they want to get it right. And I think it is great that JavaScript has one number type that eliminates a lot of confusion and eliminates a lot of errors. It just has the wrong type. I wish we could fix that.
Agreed.
Well, my favorite feature to add used to be private names, which seems to be going into ECMAScript 6 because then you have enforced privacy. ECMAScript 6 has a feature called proxies, which right now I think is a little bit complicated. And I'd like to see whether or not we do proxies and when we do it in 6 or 7. I think it would be great to have a very simple, observable, where you just could take an object and say, okay, now make it observable, and then any accesses to its properties or whatever would call a callback, sort of an eventing model. I think just doing that would ease a bunch of data binding requirements that a lot of frameworks have, and wouldn't be as complicated as trying to, because like Douglas says, there's some brilliant stuff that goes into the ECMA 6 committee, but it may take years to come out. So if we could have a simple data binding interface, that would be a great thing.
So we considered such a thing at the last meeting, and it was voted down because you weren't there. But you should come to the next one, and maybe we can bring it up again.
Sounds good.
Right on, man.
Thanks
so,
for the
hey, Felix9, what's up, dude? This is the first time we've seen you all week. Where have you been? If Shocker can be extended to run C# script subset, Will it be faster than CLR?
Well, Felix 9, that's a highly speculative question.
Sure.
I'm
It
gonna
is
say,
Felix.
I'm going to say no because I have a lot of good friends on the CLR team, and they're pretty smart. So
Absolutely.
I'm going to say no. There's a runtime for everything.
Right on, man. Kevin would like to know, does minification of JS in a Windows Store app provide any performance benefits?
A little one, so it's going to download slightly faster because it's going to be smaller. That's probably observable and would be desired. It'll go. I doubt that it goes through the compiler any faster. I would think that the Lexer goes through the white space instantly, so I doubt that you see any benefit there.
Yeah, I don't think there's load time benefit, but definitely network bandwidth.
Right on.
Is the benefit.
And there was a question up there actually that was interesting. Now that we live in a world where, you're writing these very intent, like, as you mentioned, brilliant, incredible, powerful applications, and you can view source. Like, so we know about what's going on with privacy in the world these days, but let's look at the code. How can you really obfuscate JavaScript?
You can't.
Okay.
So if there are secrets you're putting in the code that you want to hide from the people you're giving the code to, forget it. That just doesn't work. They'll figure it out.
Well, it's good that there's a general trend in the world toward open source.
Sure.
Because JavaScript is right with that trend.
Right on.
It's all pretty much open. Now, it may be that the variables are named A and AA and ZZA, and that may slow people down a little bit, but I don't think it's a big barrier to understanding what the code does in the end.
Right. The internet has taught us that slowing people down doesn't slow people down. So stuff still happens. So it depends on who you're trying to hide it from.
Yeah.
If you're trying to hide it from your competitors because they don't want to figure out how clever you are, that's not going to work. If you're trying to hide it from bad guys, that's not going to work. If you're going to hide it from people who are not going to look at it anyway, then yeah, but they're not going to look anyway, so you haven't accomplished anything.
Sure, makes sense. Nick wants to know, we talked a little bit about this earlier, but what about, JavaScript is a functional language. It's not a functional language, depending how you use it. It can be functional, it can be not functional. So what are your thoughts on functional programming in JavaScript? Are there any plans to add more FP features in the future to make it a legitimately functional programming language?
The last feature it needs, as we said before, was proper tail calls.
Okay.
And we'll get that whenever ES6 comes out.
Okay. And do you see in the wild people actually using it in the functional style?
Not a lot, but we're seeing more and more of that.
Okay.
We're seeing it especially in the libraries, but very often the very best JavaScript programmers are the guys who are writing the libraries, and they're making very good use of it.
Interesting.
Yeah, one thing that I thought was pretty neat is I've seen a lot of TypeScript programmers way ramp up on how much functional programming they're doing. And what they tell me is that the fact that TypeScript allows you to express function types helps them because then they can understand the flow of all the different functions better because they can see, they can hover over something and they can see, well, this takes this type and produces this type, and then so I've seen people program big internal projects in Microsoft with basically modules, functions, and interfaces. Okay. And it's pretty neat. JavaScript is a legitimate functional language.
Interesting. Very interesting. So it's also an IL and a bytecode for the web. Yep. But the question Lauren's asking is, what are your thoughts on a standardized browser IL bytecode, assuming that it's not JavaScript?
That's a subject that I've had a long history with. I did a company in the 90s that did a low-level bytecode, kind of similar in architecture to LLVM.
Okay.
And I think at one time that was a very good idea for the web. I think because then you would have had a diversity of languages that could have targeted this thing. And a diversity of tool chains, because if you have something that can be targeted by a linker, then it's a lot more like desktop programming. And so in terms of reuse of developer tools, having a low-level thing would have been a very good idea. I think today, the barn door is open and all the horses are running around in the field, and I don't know that community putting energy toward an LLVM-like solution is going to add a lot because there's so much energy going into JavaScript performance at this point.
Yeah.
I guess I would ask the person proposing that,
yeah.
what application class anymore are you trying to get with that that you can't get with JavaScript, and what type of programming languages are you trying to support that you can't get by translating them to JavaScript? That's kind of the question.
Well, another answer to that is we already tried it. The browsers used to have a standard bytecode engine in them, and it was called the Java Virtual Machine, and it failed. It could not run everywhere the same way that JavaScript could. JavaScript is amazing in its portability, far better than anything else we've ever seen.
Yeah, interesting. Ramon wants to know, what features of JS that are going to be eliminated in ES6 are you in favor of, and what are the implications in terms of backwards compatibility?
We're not removing anything from ES6, and our intention is to not break anything.
Nice.
We will not keep that intention because anytime you make a change, invariably something unexpected gets compromised. But we're trying very hard not to break backward compatibility.
Great.
Well, Douglas, can you comment a little bit about the evolution of the ECMAScript committee's thinking about backward compatibility? I know at one time the committee was thinking of having a different tag, text / something else. And we were really happy at Microsoft when the committee changed to be saying, no, we're going to stick with the JavaScript text tag. So can you talk a little bit about how that thinking evolved?
Netscape had experimented with tagging language versions, and we eventually realized it didn't work. And so we're trying to go ahead with one language. The one attempt we made at making breaking changes was introducing the strict mode to ES5.
Right.
And that was necessarily an opt-in thing. If you want the better language, then you say so, but we guarantee things will break. And our intention at that point was that all future versions of the language would build on that. Since then, though, more of the sloppy mode code has worked its way back into ES6, so more of that bad stuff will continue to work.
Okay.
So you have to remain compatible with the bad stuff.
Unfortunately, yeah.
That's the problem with compatibility, man.
Absolutely.
That's right, just like the x86.
Yeah.
You still have to have, the population count instruction.
What are you going to do?
What are you going to do?
So Adam wants to know, in a Windows Store app, the large JS source, I can think of a few of those right off the top of my head. Is there benefit to loading all the JavaScript at launch time, or scattering JS source file references throughout the HTML?
I can take a stab at that one. So it's actually better to specify it all up front.
Okay.
Because we have a bunch of deferral mechanisms that we use. So if we see it all in a block, it's pretty easy. So the Chakra engine, we can. One of the things that can happen is that the Windows Store can give us all the bytecode, or it gives us JavaScript code, and we can give it back bytecode. Mm-hmm. So when you download an app, when it's installing on your machine, we'll actually go ahead and convert it all to an internal representation and store it, and then we can just reload that internal representation. So that's a way that we can get much faster load time, for example. Okay. So it's the system is actually managing deferral. We defer parsing of things. So if we haven't generated the intermediate representation in advance, we'll defer parsing of anything you haven't called. So upfront is fine. Excellent. It's not like on the network where you have to spread it out so you get the network latency defeated.
Sure. It's a different model. Adi wants to know, would JavaScript work to make 3D games?
Yes, today, if they're simple enough, and if you're willing to do terrible, terrible things. In ES7, we're looking at adding some form of parallelism to the language. And when that occurs, JavaScript may become the fastest programming language in the world, because it'll be able to exploit the cores better than anybody else.
Sure, and I'm hopeful that ES7 work will include access to the GPU.
Yes. Exactly. Well, in ES6, we're looking at typed arrays that can get pushed directly to the GPU. So we'll already see some benefit in the next couple of years.
Now, what do you make of WebGL? which we now support in IE11. That's in our preview, and a lot of the other browsers have supported for a while. I mean, you can do 3D programming in WebGL, can't you? Or is it 2D only?
WebGL is just another example of how the community is going to continue to work to defeat performance problems.
Okay.
Because, yes, if I were to do ray tracing in JavaScript, that would be prohibitive. But with WebGL, you're using the GPU to do a lot of the heavy lifting.
Okay.
And I've been writing WebGL code. Is working great for me.
Right on. Excellent. Hey, thanks everybody for the questions. We have time for probably one more question. I guess maybe we don't have time for one more question. Heads are shaking. We do have time for one more question. We don't have time for one. So, just joking around, man. It's great to talk to you guys. Thanks for coming on. I mean, with the last 20 seconds, let's talk really briefly about what are you really excited about in JavaScript. 10 seconds, man. Like, what gets you pumped?
I'm amazed that we're still talking about JavaScript. I mean, it should have been a dead language by now, but it's taking over the future.
Right on, man.
I'm excited about JavaScript is like the piazza of computer science right now, and everyone's coming together and creating amazing systems.
Awesome.
And I love the energy of that.
Beautiful. So keep on coding, keep on pushing the limits out there. Thank you guys for joining us today, man. Great to see you. Cheers.